Yahya, can you turn on your mic and present your presentation? Thank you, appreciate it.
Hi everyone. Thank you for having me on this conference. It's really my pleasure to show you whatever I have here. I am trying to be as not boring as possible since this is the last one and everyone now wants just to go and just hit exit and that's it. So let me here try to share my screen.
Well, I'm sure the people that are staying here are using this time very, very well. So it's a great topics that we're discussing here. And I'm gonna do like a little wrap up of how all of these discussions that we made are related and how you can use it to benefit your organizations and the way you do work. So I'm just gonna give that conclusion at the end. Go ahead.
So, all right. So this topic I'm going to talk I'm going to talk about the weather analysis for the schedule, for construction schedule preparation and planning and monitoring phase and execution of the project. This is a little bit about me. I've been like working as a project control consultant for DTE Energy and project control specialist too for City of Fort Worth Transportation and Public Works Capital Delivery Projects in Fort Worth, City of Fort Worth. Planning gas schedule manager, also for TBC for gas turbine, oil and energy gas, senior technical support engineer, Manafsa Solutions. So I have around like roughly like 12 plus years in project control field experience. I have a bachelor's degree in mechatronics engineering, University of Technology, and now I'm pursuing my Master of Engineering in Construction Engineering and Management at University of Texas at Arlington. I have also I'm a PMP and a PMI scheduled professional SP. And right now I'm also pursuing or trying to get the RNP, risk management professional too, hopefully. So why we are trying to involve weather analysis in our schedules or in construction schedules. So I found this paragraph quite interesting. According to one of the leading statistics companies on the internet, states that time delay, achieving productivities and weather, all these three account for 60% of the root causes for cost overruns in construction project worldwide. This is pretty interesting because I'm not going to talk about the other terms because they're all known, and especially also the productivities, but weather also is really an important aspect of these among those three reasons. Construction work is really greatly affected by the weather events such as snow event, heavy rainfall, high temperature, wind, tornadoes. All these will affect the work. As my experience, like I worked as a contractor and as a client, so I would say I face all these conditions in my work. Like I've been, we get like a high temperature as 135 Fahrenheit. Where the work has to stop, no more work had to be done, so work was postponed. The same thing for snow and heavy rainfall, that everything would be stopped due to that reasons. The wind and tornadoes also would affect structural work, hauling and stuff also like related to the construction work. All these conditions is really affecting and would just postpone the work and have like extra delays to the schedule. It really needs to be prepared and needs some planning ahead. Considered as a high risk, then it's really need to get a potential risk response to be prepared for it too. We can't just like leave it as it is, wherever we're gonna face. We have to plan for it. We have to prepare also risk and the contingency. So with all that said, the best way to do that is by predicting potential schedule delays caused by weather conditions is really necessary. And here is where we want to talk about the weather analysis. So weather analysis is really one of the most important aspects of to be considered when creating a construction project schedule. Honestly, in my opinion, like most of the contractors, like they neglect that part, unfortunately, and that would cause problems. So when weather impact the schedule, the major like idea is we do change order, we get the extra days, we get the extra time, fix, that's it. Well, this is not okay because this is considered as a poor planning, I would say, because you are building your schedule assuming that zero weather impact will be, there's a zero impact for the schedule by the weather events. There will be no weather events. that lead us to be creating an unrealistic schedule. And this is something that really need to work about, that to have a realistic. This is one of the actual reasons we want to do planning and creating a schedule. Being in the planning ahead is to have a realistic schedule and transparent too. So so you also can't build a schedule based on 0% weather. So there's other ways that conducting the weather delays and schedules, which is this is some like rarely used. I just want to mention it, not to use it, but as a bad exercise also, is by prolonging activity durations in the schedule for some activities. And this term in as PMI, this term is called as padding by adding extra days, extra unusable days to some activities, just to account for weather impact to these activities, make sure that these activities will having these extra days as an impact. Well, this is not right, because for some reasons, this is you're gonna have like extra days that you don't need them in an activity. It will be hard. It eventually will be hard to manage these these activities when you have it as a long one. When you add it like unneeded activity, unneeded days to it, this is going to be hard to manage. Believe me, that's one of the things. Also, eventually this will add also float, and for as a client point of view, extra float is really not welcome in having the schedule. Everything should be calculated correctly. And also, like one of the things that I would say eventually it will affect the schedule is having some activities get into the critical path, which they are not when you do the update cycle during the work, during the execution cycle. It will take some time to really get to investigate the reason why was the problem. Then you get to, oh, these activities are like too long, it shouldn't be that long. So this exercise is not really okay. I'm just mentioning it just to let you know about it. The other way that is, like, I would say commonly used, and it's a good way also, it's a good one, is by, we call it as adding a buffer activity at the end of the schedule, construction schedule, and that buffer activity will account for, have a specific days to accounting for a weather impact. It could be calculated, which is good. It could be not, just a number of days. Either way, it's a good way, but it's lacking one important thing. What it is, so when you build your schedule and have a buffer at the end, you are not accounting for the weather impact during the execution cycle of the project. So you just accepting the risk by adding an allowance or contingency duration at the end of the project to as a risk response just by the end. So why it is like you're not like accounting for during the execution. If anything happens in the middle, you will have like some of the milestones will be affected. You will not meet some of the deadlines or some of the major milestones during the execution. This is something you really need to check and to be addressed. And it is important also because we are not just trying to get to the deadline, we're just trying to get to every milestone to be and the specific and transparent duration correctly. So with all being said, that the best way is to address the weather analysis or to address weather impact in the schedule is by conducting a weather analysis, creating a weather calendar in P6 or the scheduling tool, and add these days to these calendar to the specific activities that will be affected by the by this weather events. So conducting weather analysis. So how to do that? I'll just try to be talk about that briefly. Try not to be too long. So first thing, what we do is we check the historical weather events for the last 3 to 5 years. The longer, the better. I don't want to say like more than 5. 5 will be more than enough and will be good when you check the events for the last 5 years. How to do that? We go to specialty weather forecast websites. There are a lot of them. You have weather.com, weather.org. I, for myself, would like to use 2 websites. Weather Underground and AccuWeather.com. They are really good, easy to manage, and they have all the information you need. So how to do that? After like getting the information, we go to and create a table for each year and month through the whole 5 years, and to calculate the average number of weather events. I just put like a snapshot here. I'll try to show you just so quickly how to check that. It's pretty easy. This is like Weather Underground, and this is AccuWeather. So let's head there, like Weather Underground. So it's pretty easy. What I'm just going to talk about that very briefly. So we go to historical weather, and here, like you just mentioned, where the zip code or the city. So let's say this is Detroit, and we view that. Then we go to select monthly. Then we choose that we want to go 5 years. So we go to 2015, January, and then we show. We're going to do this exercise for every month in each year for the last 5 years. It will take roughly like around an hour, maybe more a little bit, but it's like worth the time you spend. So what we focus in here, we go there to the to this table. This is what we need. This is how the information we're going to need to create our table. This table has the days for all month duration, like January, February till December for each year. What we focus here is we want to know the average temperature during that durations. We want to see also the average wind speed and the precipitation. So each one of those would affect the work. The high temperature, like I would say, like here maybe it's 115. More X plus that would postpone the work because it will be like extended heat. Also for the wind speed, this will affect the hauling, the structure steel work, the hauling work, for the wind. If it's like been like passing, I would say 20. That's based on OSHA. And again, this is also that go to the crane specification. It could take more than that, but just as OSHA requirement, we would say 20. And the same thing for the precipitation, like always looking for myself, what I do is I look wherever it is like more than ½ inch, that will affect the earthwork activities, the excavation, backfill, and all this stuff. This will be affected if we're gonna have a precipitation like more than ½ inch in specific days. So these are the information we're looking at. We go to each month, we copy that to the table, and we're trying to create a table to have all this information. I would say that's after like conducting all this information. So we go to this table. So I'll show you how that is an Excel sheet. So we take this information. So we get the information from the weather forecast websites. We get the every year, every month here for January 2018, 2019, 20. The same thing for February up to December. So I didn't fill this table all of it. I just want to show you how to do that. We get the information. We do some here like conducting some formulas to see wherever we have that amount that like the wind, the temperature, and the precipitation, the conditions that we considered as weather events. So we get the number of days that we're not going to be able to work in each month or each year. Then we get the average in these three months. That was the average in January, was the average in February, was the average in March for all these years. And then we go and create our weather calendar in P6 or the scheduling tool to account for these days. How to do that? So we go to Primavera. And I'm gonna say about Primavera here because I'm using P6 stack Primavera for this for the cause of this one. So we go to create a weather calendar, and then we go to the month, like for January 2021, according to what we have in here. We ending up having an average of 1 day. In February we have 4 days. So we go and choose like specific days, wherever days, just say we're gonna have 4 days here, 1 day in January, and so on. After having all these and working days conducting our weather calendar in P6. Then we go to the specific activities in P6 and assign these calendar. So we're not gonna have only one. We're gonna have one for weather calendar for earthwork, one for the structural steel, and one for the overall. Each one because for each criteria. When we add those to the activity, this is then gonna be calculated in the durations for the activities and the deadline of the project. So after like doing all these activities here, we're gonna have like, I would say, a more realistic schedule. Why it is the best way to use it? Well, for some reasons, it keeps the original duration for activities. If we compare it to the other ways we talk about, we're gonna keep the original duration for each activity. We're not gonna padding or adding some different like unneeded durations to the project, to the activities. We're also gonna build our schedule based on historical data and addressing accurate weather events. And by doing that, comparing it to the other way, we are like we are making sure that we're having the weather impact during the execution cycle of the project. We're not just accepting the risk at the end and adding contingency. No, we adding contingency, but it will give also more realistic deadlines or milestones during the execution cycle of the work. So for these reasons, I would say this is like the best way to conduct like weather analysis and add it to the schedule. This is also one of the quality measures for the project schedules that need to be conducted in the planning very early. And it is also one part of the considered to be considered in the claim analysis later on. This is a different whole topic that we can talk about this in a different time. But for now, I'm just trying to make this very briefly since we don't really have time. If there's any questions, I'm ready to answer. And Annie.
Thank you. Appreciate it, Yahya. For some reason, my mic wasn't turning on, but greatly appreciate it. Yahya, you did a great job on this weather forecasting. Is this something you do during the project or just as a forensic analysis of the schedule, like after you get into claim management and you want to find out when were the weather days or put that weather calendar in your schedule?
So yeah, it is important. It is like what I'm talking about right now is during the planning phase of the project of creating.
So these are like future dates, because how would you get the weather for future dates?
Yep. So we get the historical data to base that
based on the historical data.
Based on the historical data, we want to get an average duration that we're gonna face in our work in the future. This also can be used in claim, like when the contractor submits a claim for some days to have extra days, we go and check. Sometimes it go really in details in each day and checking the criteria for these days, what was impacted, whether these activities are on critical path or not, these activities that is affected by the weather. Also, like if other activities can be done or just this one, and how long. So many aspects can affect the claim when we use this in the existing situation or the past, like when we pass this. But
so Sam is asking, how do you hold your contractors to this? Are you embedding or incorporating these results into the contracts when you do with contractors, or just for self-performed planning?
Well, this is like, I would say it's not like it's a process of the company. So some clients would give you a list of the weather days, would say in the contract, these weather days, because they already conducted a weather analysis.
15 days.
They already
weather days, for example.
They already conducted a weather. Some companies, they already conducting weather analysis, client, and they give you the number of days. They say each month should have this number of days as a weather, because they want also, even the client, believe me, always looking for a realistic schedule. They don't look just to give you a schedule that will meet this date. No, it really need to meet the days with the with the right days or right durations and incorporate all the risk in it.